Hi everyone, I'm going to do review set 4B. Make sure you guys can do all of chapter 4. Um, here we are. Review set 4B, page 125. Now the first one's a Riemann sum question, pretty typical to what would be in a test. I'm going to draw it. So we've got an upside down quadratic. It's a minus x squared plus 4. They've written 4 minus x squared. I'll write it the same as the book. F of x, 4 minus x squared. This is crossing at 2. If we're doing Riemann sums, we're putting in 4 partitions in this question. Right, and the question is saying come up with area estimates and write them like this. So we want area A to be smaller than the definite integral from 0 to 2. Right, so this, like the domain on this parabola is restricted just between 0 and 2. And then we'll have an upper estimate. All right, so we're going to use rectangles to find area A. We're going to use rectangles to find area B. You'll have to think how am I going to get the smaller area? How am I going to get the bigger area? So if I go from the left, I mean from this point, coming out this point, I'm going to end up with area B because I'm going to end up with an overestimate. If I go from the right, maybe use a different colour, to there, to there, to there. So, and then the last rectangle's non-existent. If we're taking it the heights of our rectangle, we can take them from the left or the right. Okay, one of them will always give you an overestimate, one will give you an underestimate. Right? So this question you'd have to figure that out. To get our underestimate, we'll need the heights coming from the right. Okay, so we'll do that. Area A, it's 4 rectangles. They're all length times width. The width is always the same. So I'll write that first. Between 0 and 2, what's the width? If we need to chop that up into 4 rectangles, it's 0.5, right? Then I'll have, that'll be times by the height, which will be f of 0.5 if I'm going to the right, plus 0.5 f of 1, then I'll have 0.5 times f of 1.5 and 0.5 times f of 2. Okay. Now, I'm just going to put the numbers straight in. I don't have a very big whiteboard. So we'd have 0.5, what's f of, so if I put a half in there, that would be a half squared. I'll have 4 minus a quarter. That'll be 3.75. Then I'm going to put 1 in as my next height. So width times f of 1, which will be 4 minus 1 squared. That's 4 minus 1 is 3. The last height's easy at 0, but we've got to get there. So the third height will be f of 1.5. 1.5 squared is 2 1/4. 4 minus 2 1/4 is 1 3/4. Let's write 1.75. And the last height is 0, so the whole area of that rectangle will be 0. I've got to add all that up. And how am I going to do this? What about if I add them all up and halve at the end? It might be easier. So 3 3/4 plus 1 3/4. is 5.5, plus 3, 8.5. Then I'm going to half 8.5. So I get area A will be 4.25, 4.25 units squared. Okay, we'll do the same process with our upper rectangles with area B. Now some of these numbers will repeat, which is nice, but the first one won't. So the first height is coming from f of 0, 0.5. Question like this, you should be showing you're working out. So when I put 0 into this function, I get 4 minus 0 squared, which is 4. Now some of these values are now going to repeat themselves. The next height for this rectangle, the height I need comes from the left, where the x value is 0.5. So that corresponds to the first one from area A. If I put 0.5 into the function, I get 4 minus a quarter, 3 3/4. This number, hopefully I've explained myself well and you understand why I'm just copying down some of these now. Okay, 4 rectangles again, but the heights are coming from the left if we want an upper estimate of area here. Right. I'll try the same thing later. We can do this. I can do this in my head, surely. Right. And I pull the heights and then we'll divide them by half because we get the same answer. So we've got 7 3/4, 10 3/4, 11 3/4, 12.5. 12.5 divided by 2 is 6 1/4. Alright, so now this statement up here, we know that our true area, right, the true area as represented by the definite integral lies between 4.25 and 6.25. Okay. If you want an estimate for that area, the estimate would be to average, right? So draw a line in the sand here. Estimate of area would be average area A and area B, right? So, sorry, my computer has just logged out. Hopefully the video kept going then. So be 4.25 plus 6.25, that's 10.5. 10.5 divided by 2, and you get your estimate 5.25 units squared. It's probably reasonably close to the true definite integral area. So that was question 1, I believe, from review set, and I'm going to go through the whole thing, but I will do it one question at a time, so we'll stop.